Alright, welcome. Let's take a look at a problem with this fancy yellow car and a cliff. So we'll take a minute to read this. And as usual, if you're watching one of these things, you can pause it at any moment and go at your own pace. So basically what we're going to try to figure out is if this car was speeding in the 50-kilometer-an-hour zone. The police got there, they know that it landed 18 meters from the base of a 5-meter high cliff. So usually the first step that we're going to want to do is to draw a little picture of the situation. So in this case, we'll draw our 5-meter high cliff under our car. And I'm going to label it as negative 5 meters because I know it's ending lower than where it began. Right? Now, Vx is what we're going to try to find, and we know that dx is 18. Now, this drawing's not quite to scale. So, okay. I'm trying to get a sense of what's going on here. Now, we'll make a list in the x direction of what we know. So we know that the displacement is 18 meters. We don't know the horizontal velocity or the time. So there's not a whole lot we can do right now in the x direction. What we'll need to do is to go over into the vertical direction so that we can find time. So we do know the displacement vertically was negative 5 meters, and we actually do know the initial vertical velocity because it's not moving up or down at that moment, so it's 0, and of course acceleration is due to gravity, so it's negative 9.8 meters per second squared. Now the tricky part is trying to figure out which equation works best. Now we definitely need one that has time in it, and we also want variables that we know. So in this case, it looks like the furthest to the bottom left there, that equation seems to be the best, and it actually works out really nicely because when we plug our values in, the initial velocity is 0. Now it's a good place right now to pause and follow along, make sure you can get the same answer that we're going to get. Right, you need your own calculator to do that. Now when we rearrange this, solve for t, we square root both sides, we should end up with about 1.01 seconds, and notice I'm going to keep all those extra decimals in my calculator because I don't want to round this yet. It's not my final answer. So now that I know the time that it took to fall down the cliff, I can use that time in the horizontal direction to help me solve for the horizontal velocity. So when I take 18 meters, divide it by 1.01 seconds, it's just gives me an answer of around 17.81 meters per second. Now that doesn't help me yet because the speed zones are in kilometers per hour in Canada, so we need to convert. And when we do this, check in our units, we end up with kilometers per hour, and the value is 64. So it does seem like they were speeding. Alright, thanks for watching, and hope you found that helpful.